Okay, hello everybody. We're going to look at our fourth lesson today, all about factoring trinomials. Now we'll start with those trinomials that do have that coefficient in front of x squared, that leading coefficient. We're going to take all of the ones that have 1 in the front. So we'll take a look at this using some algebra tiles first, just to visualize what's about to happen. And then we'll talk about the rule for algebraically, how we would approach that. So the polynomial expression that is represented by those tiles, there's one large x squared, 1, 2, 3, 4, 5, 6 x's, and 1, 2, 3, 4, 5, 6, 7, 8 unit tiles. So our polynomial, and let me change the blue here, that will be an x squared plus 6x plus 8. Literally, that is the polynomial represented by those tiles. Okay, the algebra tiles can be arranged into a rectangular form, as shown below. There are no gaps. The x's must line up with x's, ones with ones, all of that stuff. Just like we talked about before. We talked about really making sure the dimensions matched up. So we're going to do the same thing here. And here's one possibility of how that could be drawn. Okay, write an expression for the length of said rectangle. So if you were to imagine coming up with an expression for both the length and the width, we would be looking at the dimensions of those tiles on the outside. So here's a dimension of x, and then you have it 4 ones essentially down the side. Now I know these are x tiles, but the dimension that's here, as you can see by my cursor, that dimension is actually a 1. Okay, now we can look along the top, and you can see dimensions of x and 2. So the expression for the length is obviously the longer of the two sides, so that's going to be an x plus 4. Our width is going to be an x plus 2. Okay, we can then write out the area for this rectangle as the product of two binomials. Now for those of you who are thinking this looks very, very familiar, that's because all we just did was essentially multiply those binomials in reverse. When we talked about in our last lesson was we called that factoring. As long as we can write the product of two things, of two items, their result is actually the expanded polynomial form. So when we actually represent the area of this rectangle, really what we're doing is the length multiplied by the width. So if we were to expand that set of brackets to actually do that binomial multiplication, you would see that you would get an x squared plus 4x's plus 2x, also plus 8 on the end. Now if you look exactly what you had in those algebra tiles, that grid, that array, that area model, whatever you want to say there, that's exactly what you have. You have an x squared, you have 4 x's, you have 2 more x's, and then you even have your plus 8 attached on the end, okay? So it is really, really, really similar as a concept. They are very related. And we can take a look at this one as well. So use the following set to answer the next question. So we've got a polynomial expression which is represented by those tiles. 1x squared, sorry, 4 x's, 4 ones. So our expression is an x squared plus 4 x's plus 4 ones. Okay, arrange those algebra tiles into a rectangle. State the dimensions of the rectangle and an expression for the length and the width. So now we're actually asked to do the thing. So let's make ourselves a little grid, try to keep ourselves as organized as possible. I'm actually going to change those so they are straight lines. That's not a straight line. That's a straight line. Where does it go? There we go. And here we go. Okay, so our squares are always going to go up in the top corner. So I know one of my squares, actually my x squared, the only one I have, has to go here, and it's positive. Now, if I take those 4 x's that I have to work with and try to arrange them in here, I have a couple options. I could choose to place 2 of them where I have placed them, and I can place 2 underneath. Right, really these are the regions where x is going to be allowed to be, up in the top right and down in the bottom left. And that leaves me with just enough space to put in my 4 ones. So this arrangement will work. If you try a different arrangement, it might not actually work to make a rectangle. You might not be able to fit everything in where you don't have those gaps if you were to imagine squishing everything back together. So my dimensions then, I'm going to have an x and 2 1s along the top, and then x and 2 more 1s down the side. So our actual polynomial in factored form, okay, the length and the width of that rectangle multiplied together. Now actually this is a square, since the length and width are actually the same dimensions. So this will end up being an x plus 2 multiplied with an x plus 2, or if you've recognized it already, that could literally be an x plus 2 sized square. Okay, algebraically, that's what this means. You have a square with length, or side length, x plus 2. Okay. Now we could complete a few of these just to make sure that we can go from one to the other. Now I think for the sake of time here, I might only just do one. So I'll take the one. Let's do the grid view instead, and we'll go that way. So if I start with this grid, I know that I've got an x plus 1 and an x plus 4. And that's exactly what my factors tell me, right? And again, the factors are those two things that multiply together to give us our original expression. So if I were to actually, sketch my rectangle, because my grid's actually completed. This is just what we want, kind of the skeleton. So if I sketch the rectangle, then I'm going to have, my x squared. Hopefully this makes a rectangle. No. Actually, I want it to be a square because there we go. There's an x squared. I know I'm going to have 1x. I know we're going to have 4 x's down this way. And then my 4 1s will be able to fill in. Okay, and again, they're all positive, so give yourself a little bit of shading just so we know for certain that yes, they are positive tiles. And then our polynomial obviously is all of those tiles. Basically, their polynomial expression that corresponds with it. So we have 1x squared. There are 5x tiles and 4 1s. So if you were to actually expand these factors and actually do that multiplication, you would end up with that polynomial in the beginning. So that's how this chart is kind of working. So again, I'll fill it all in for you so you have them if you would like to try them out at any point. Now, given this polynomial, so in this format, we are trying to find two numbers that multiply to a times c, but also add to b. So really what we want here are two numbers that multiply to our constant. Now the reason why it says a times c is because that's going to tell us that a is 1, c is the constant. So really what we're trying to do is figure out a way to split up these x's so I have the right amount in some groups. So if you think about this in terms of our picture up above, our x's will always get split up into two groups. Okay, our x squareds and our 1s, they basically are always combined together in their respective places, but it's the x's we have to worry about splitting up into parts. So we have to figure out the correct combination of numbers that will allow us to split them up to make this rectangle or square. So that's the goal here. So if I take a look at A, I'm trying to find two numbers that multiply to give me 8. So they're going to multiply together to give us 8, but they're going to add together to give us 6. Now you can think about a couple combinations of what multiplies to 8. 1 and 8, 2 and 4, and I think that's it. Those are all of the things that multiply to 8. Now there's only one of those pairs of numbers that will ever add to 6. Okay, be it positive, negative, whatever signs you have to use. The only pair you can choose here is 2 and 4. Now, the reason why we're doing that is because we really want to make sure that I can group those 6 x's in such a way that they actually add to give me that middle one, because if I represented it as a grid, I would have to multiply them together to get me the 1s. And I can show you the grid as well. So here's my x squared. That gets split up to being a 2x plus a 4x plus an 8. So we'll go through this whole process, then I'll show you the picture maybe on the side here. Actually, you know what? Let's draw it in as we go. Okay, so my original polynomial, I had to take an x squared, I had to take 6 x's, I had to take 8 1s, and arrange them as a rectangle. This is how we would have started before. So I know from before that my squares always go in the top, and I know that doesn't look like a square, but let's pretend. So I know that that's where those are going to go. And we'll move this right here so it's better. Now I know that I have 6 x's that I have to group in somewhere. Okay, and they have to be in 2 different spots. I know that I have 8 ones to deal with after, but maybe we can deal with them first. 2, 3, and there's 4. 1, 2, 3, and there's our 8th one. So by looking at this now, with our x squared in place, our 8 ones in place, there's only, one possibility for where my x's can go. And if you look, there's a group of 4 x's that could fit in this place, and there's a group of 2 x's that can fit here. And conveniently, those are exactly the same 2 numbers that we had. So I'm going to place 2 x's horizontally, and my other 4 will go vertically. So this is part of the reason why we're really looking for 2 numbers to multiply and add to something. Because really the x's are in 2 places, so I should have 2 numbers. Now we're going to see what our factored form is algebraically in a minute, but really this is x plus 4 and this is x plus 2. And again, you can see those numbers keep coming back. So let's take a look, jump back into our algebraic method. Now we talked about something in our last video where I had 4 things, and we did an example that actually had some groups of things. So we just had brackets around them. Now that plus sign in the middle is going to stay in the middle. Don't put it as part of the brackets you're making, because this changes then to a multiply question, and we don't really want that here. So now that I've made some groups, we're going to take a look at each group independently of the other one and see if there's a common factor inside. Okay, that's going to help us when we go to factor this. So a common factor between x squared and 2x will be x. So x squared divides by that common factor to give us what's left over. So x squared over x gives us just x. 2x over x is 2. So x plus 2 we can currently see, just like we kind of thought we would have. Now the other one, we can take it a 4, and we're left with an x again plus 2, which is a good thing. So now that our brackets are the same, we can kind of look at what we did in our last video. So that's going to essentially be my new common factor between those 2 large terms, x plus 2. And then the other factor comes from the greatest common factors of each grouping, so x plus 4. But look what just happened. That is exactly what we said it would be, comparing it to our algebraic method. So by finding those 2 numbers, how we can split up those x's into their respective groups, we can actually do the exact same thing algebraically versus with the tiles. Okay, so maybe we'll just do one more here, because even if the letters change, the process will not. So let's take a look maybe at, let's take a look at E. And again, I will make sure that you have all of the answers so you can try some out on your own. Now if I look at this, I'm not going to draw the picture this time. We'll keep it to the algebraic method here. So if you want, you can refer to the picture up above, because I don't really want to draw 26 ones tiles, and I don't think you want that either. So we're going to find 2 numbers that are going to multiply to give us negative 26, but those same 2 numbers have to add up to however many x's I have. So I need to make sure I add them to give me negative 11. Okay, because remember, we're going to split those x's into their 2 groups in that grid, and they do have to add up to the right number of x's, but they multiply together to give me this grouping of ones. Okay, so 1, 2, 3, 4 x's along the top, 2 horizontally. That little grid creates those 8 ones. That's why we multiply. Okay, so let's think about some things that actually multiply to 26. So obviously, you have 1 and 26. Now I know it's negative, but we can play with the signs after. So 1 and 26 multiply to give me 26. 2 and 13, I don't think there's anything else. Either way, it doesn't matter, even if there is, because 2 and 13 will definitely add to 11 in some way. So now I have to make sure that my signs are right. So I need to be negative 26, but my addition, when I combine them, I have to add to a negative number. That means I want the bigger number to actually be the negative one. So I really want this to be a negative 13 and a positive 2. When you add them, you get negative 11. Your integer rules tell you that. Same thing when you multiply, you get negative 26. Again, straight from your integer rules. So we can use those 2 numbers to help. So we're going to split up that middle term, and it will be an n squared plus 2n's minus 13n's minus 26. So really this method has a name. And most people will call it, the decomposition method. And the reason why, you're literally taking that middle term and you're decomposing it into its two base parts. Really, these two parts are what goes into that algebra tiles grid. So that's why you sometimes might hear it called the method of decomposition. There could be a couple other names as well. Okay. Now when we actually go to factor this, remember that I see four things here. So this is where we're going to start to make some groups, and we're going to place the first two things in one group, the last two things in another group. But here's where I always see students make their mistake. Okay, so the first two items can go in a set of brackets, no problem. The issue is this subtraction sign. Now just like before where it was addition, we're going to leave that on the outside. But then when I introduce a set of brackets, you've basically taken out the negative from this part of the expression. Now, because we've introduced a set of brackets, we have to make sure that we change the signs of things to make this work out. So it was, in the beginning, it was negative 13. In the brackets, though, it becomes positive 13, because imagine distributing that negative sign back in. Negative 1, technically, multiplied with 13, gives me that negative 13. So I have to remember to change the sign on the 26 as well. Okay, because when you distribute that back in, that's where that negative 26 is coming from. If you don't and you forget to switch the signs, your brackets won't be the same. One will be positive, one will be negative, and it won't work out the way you think it will. Okay, so now that that's taken care of and we remember to deal with that negative, we can look for common factors of each group. So this is going to become an n. That's going to be an n plus 2, which again is very nice. Look at those numbers. That's a 2 that we put in that box. Then we got a minus, and we'll factor out a 13. And again, you will be left with an n plus 2. Okay, and it does work out. And remember, if it's now negative 13, multiply it inside, you get negative 13, and then you get your negative 26 from the other one. So it does look good. Last step here, n plus 2 as the common factor, and then n minus 13 after that. And look at those numbers. Plus 2, just like we said, minus 13, again, just like we said. So for anybody wondering if there's a shortcut, absolutely there's a shortcut, but only if a equals to 1. If a equals to 1, once you find those numbers, you can directly put them into those sets of brackets. Those are going to be your two factors. Those two numbers with the variable in front of them, and the following, the signs, just follow them. Okay, so absolutely there's a shortcut. The rest, this is the same process we will use for when a is not 1. So it's just very helpful here to recognize that for this type, there is a shortcut. Okay, so again, I'll leave the other ones for you. And this brings us to the last one. Again, we'll just do one of these and we'll take care of a. So these are still what we call simple trinomials. However, you may have to factor a greatest common factor out first, or there may be more than one variable. So I don't know if there's, there is some with more than one variable. So maybe I'll leave that one as a challenge one for some people. And again, I'll put the answer in there as well. So here, if we look at this, my a is not 1 at the moment. So this makes this a little bit tricky right now. So let's see if there's a greatest common factor that comes out. So each of those coefficients, 5, 35, and 60, they all share a common factor. Right? It's usually going to be that a number, the number in front of your x squared, your leading coefficient. That's usually going to be what your greatest common factor is. So we'll take out a 5 from each term. Inside the brackets, that leaves us with an x squared minus 7x plus 12, I believe. Yeah. So there you have it. Now, inside the set of brackets, that looks like something we could potentially deal with. That looks like something we can factor. So we're looking for two numbers that multiply to 12 this time, multiply to 12, but adds to negative 7. So we'll think about some numbers. It's much easier to think about the things that add to 12. There's more or multiply to 12. There's more possibilities for the addition case. So 1 and 12, 2 and 6, 3 and 4. And very obviously, 3 and 4 is going to be the numbers I'm going to try to add to a negative 7. Now, I'm multiplying to a positive, so both of those numbers should be negative for this to actually work out. Now, we just saw that there was a shortcut here. there's a shortcut when a is equal to 1. But I do have to remember that there is a greatest common factor of 5 sitting out front. And when you go to make those factors, you're going to make those factors, those two sets of brackets for yourself. Your variable in the question is going to go in first. The numbers, those integers, are going to go in second. Make sure you take the sign with it. So that's going to be a -3 and a -4. And there you have it, all factored. It's perfect. There are 3 factors here, 5, x minus 3, and x minus 4. They all get multiplied together to give us that original one. Okay, so make sure you check the solutions key whenever I get that up there, or as soon as you see this video, the solution key will be up there. So you can try out a bunch of them that we didn't do and see how you did. So again, check back in the next video where we're actually going to look at ones where maybe I can't take greatest common factor out, but there's still a way we can factor them. So again, I hope this is helping. Follow me on Instagram, follow me on Twitter. Reach out to me, I'll help you out if you need anything, teachers included, if you want to know like how I'm setting all this up and doing all of that stuff. So I look forward to hearing from people, and as always, I'll see you in the next one. Take care.